Hello. In this video, we're going to go through learning targets 723 and 724. And we're still talking about surface area and volume, but today we're going to talk about pyramids and cones. We've previously discussed prisms and cylinders, and these are very similar, except you can see that in pyramids and cones, we only have one base. In prisms and cylinders, we had parallel bases, and there were two of them. And so let's do a quick definition of pyramids. They have one base with triangular faces that meet at a point which is called the vertex. And so if you haven't already, if you could, make sure you get a sketch of this. So if you want to pause it, it's easiest to draw the front face, this front triangle, and then do like the triangle base, and then connect the corners. And just like with prisms, pyramids are also named by their base. So you can have, this one is a triangular pyramid because the base is a triangle. You could have a square pyramid, which are very common. You could have a hexagonal pyramid. As whatever the base is how you name it. And a cone is just a special type of pyramid, and it's special because it has a circular base. And then again, make sure that you draw a sketch of this. So the best way to do that is to draw like the top part of a triangle, draw an arc for the bottom instead of straight across, and then finish that arc to an oval. So now we are going to talk about the formulas. So I'm going to scooch this up. And the formulas, you're going to be given a bank, like I mentioned in the previous learning target, of all the formulas, and you need to know the difference between each one because they're pretty similar. So today, for surface area and volume, we're talking about the pyramids and cones. And surface area is SA equals capital B plus 1/2 capital P lowercase l, and I usually do that in cursive, because a lowercase l sometimes looks like a 1. And to be able to use this formula, the base does have to be regular, which is what we're going to be looking at. It's pretty common that they're regular in general, but it is a requirement to be able to use this formula. But those are the ones that we're going to look at. And then volume is 1/3 capital B lowercase h. And most of these variables are the exact same as the prisms and cylinders part. P is still perimeter of the base. B is still the area of the base. H is height. The only one that's new is this cursive L, and that is our slant height. So you can see the difference between the slant height is like on the face, so you can imagine it's like the diagonal, and the true height is like if you drop a line straight down from the vertex to the middle of the base. So to tell the difference, the easiest way that I know is surface area. If you have two bases, like in a prism, you should have 2B. And in pyramids, you just have one because there's just one base. So make sure you have this written down, and then we're going to go through a couple examples. So in this first example, I want you to do your best to draw this pyramid. How I think is easiest is draw the front-facing triangle first. Then draw the square base. You can see this side is solid. The other two are dashed. Make that look like a square. And then connect the corners. So for surface area and volume, in the previous learning target and in this one, it's really important to organize our work and to be able to find those 4 variables first. So I like to organize my work in columns. So I'm going to do like a column for P, B, L, and H. So P and B both depend on what shape your base is. So P is the perimeter of the base. I have a square and all 4 sides are 9. So to find the perimeter, I just do 4 times 9, which is 36. Then the area of the base, again, it's a square, so it's just base times height or length times width, which is just 9 times 9. So I get 81. And then typically you're only going to be given one or the other, either regular height or the slant height, and you have to figure out which one you were given initially. I like to figure that out first. So in this case, I see that I have 15, and it looks like 15 is if I dropped a line right from the very top down to the middle of the base. So that's my true height. My vertical height is 15. And then whichever one you're not given, you are going to use Pythagorean theorem to find. Use Pythagorean theorem. So I like to pull a triangle out of the pyramid, and I'm going to kind of draw on top of this so you can see where I'm coming from. But imagine like this is the height of a right triangle, this is the width, and then this is the hypotenuse. And so you're going to imagine taking that slice out of the pyramid, and I actually like to redraw it outside so I can see what parts I'm given. So I know the true height is 15. This width down here, it's not 9 because 9 goes all the way across, and you can see in our triangle we only go halfway. So I cut that in half to get 4.5. And the slant height is what I don't know, so that's L. And then I can set up the Pythagorean theorem. Since L is the hypotenuse, it goes on its own side. And then I have 15 squared plus 4.5 squared. I can type all of that into a calculator to get 245.25. And don't forget to square root it to get that your slant height is 15.7. And then once we have all of our pieces, now you can actually go back and plug them into the surface area and volume formulas. For the Pythagorean theorem, just be really careful that you set it up correctly so that the hypotenuse is on its own side. So in this case, L is on its own side. And then don't forget to square root. So when I plug these in, my surface area formula, I get B, which is 81, plus 1/2, P, which is 36, and L, which is 15.7. And you can plug this entire thing into your calculator. I actually changed the 1/2 part to 0.5. I find that the easiest. So I'll do like 81 plus 0.5, parentheses 36, parentheses 15.7. And you get 363.6. And this is in feet squared. And then you can go ahead and find volume, which is 1/3 the area of the base times height. So B is again 81 and H is 15. And there's 2 ways you can type this in. You can either put 1/3 in parentheses, or you can do 81 times 15 divided by 3, and you get the same answer. So divided by 3 and multiplying by 1/3 are the same thing, so you get the same answer, which is 405 feet cubed. So now make sure you pause this and have all this work down if you don't already, and I want to show you an example of a cone. So go ahead and pause it and draw this cone, and then come back. And I am again going to label my work, so perimeter, area, slant height, height. And the only difference of a cone versus the pyramid is that the base is a circle. So you're going to have to use a formula for both perimeter and area. Perimeter, remember, is the same thing as circumference. So we use the formula 2 pi r, and area is pi r squared. It's nice because in this base we're actually given r, so we can set this up like this. And I'm not going to actually solve for everything yet because I'm going to have you finish this one out, but this is how we would set up. And we just have to remember that the perimeter of a circle is the circumference. So that's kind of the tricky part there. And then for L and H, remember, we're typically only given one. And in this case, we're given the slant height. So you can imagine the slant height is like the outside of an ice cream cone. If you drag your finger across from the bottom to the top of the ice cream cone, that's your slant height. The actual height is like on the inside of the ice cream cone from the very bottom to the very top. So in this case, we're given the slant height is 12. And then to find the actual height, remember, bring out the triangle. So we're going to have a right triangle coming from here. So my height is what I don't know. My slant height is 12. And then the radius is halfway across, so that is 4. Now be careful when you set up the Pythagorean theorem because, remember, in our previous one, what we were trying to find was the hypotenuse. In this case, what we're trying to find is here. So you would actually set this up h squared plus 4 squared equals 12 squared. And then you would need to solve that. So I'll have you continue and solve for that one as well. And then you can take your answers for all these and plug them in to find your surface area and your volume. I want you to try it on your own, and then when you unpause it, I'll have all my work and the answers so you can check. And there we go. So I have my answers for each of our variables up here. For H, just be really careful that you changed 4 squared to 16, 12 squared to 144, and then subtracted 16 from both sides. Then take the square root. So when you plug it in, you should get an answer of 200.9 for surface area and 189.5 for volume.